NASA finds space evidence of ninth planet. In the outer solar system, a gigantic planet has been observed to follow an odd, greatly extended orbit. According to Caltech astronomers, the object, which scientists have dubbed Planet 9, orbits the Sun on average 20 times further away than Neptune and has a mass roughly 10 times that of Earth, which orbits the Sun at an average distance of 2.8 billion miles. In fact, only one complete orbit of the Sun would take this new planet between 10,000 and 20,000 years to complete. The planet's existence was discovered by Konstantin Batygin and Mike Brown through mathematical calculations and computer modeling, although they have not yet made a direct observation of the item. This would be a real ninth planet, says Brown, the Richard and Barbara Rosenberg Professor of Planetary Astronomy. There have only been 2 true planets discovered since ancient times, and this would be a third. It's a pretty substantial chunk of our solar system that's still out there to be found, which is pretty exciting. According to Brown, the hypothetical ninth planet is so massive, 5,000 times the mass of Pluto, that there should be no question as to whether it is a legitimate planet. The gravitational center of the solar system is dominated by Planet 9. Unlike the group of smaller bodies today referred to as dwarf planets, it actually controls a bigger area than any of the other planets that are currently known, which in Brown's words makes it the most planety of the planets in the entire solar system. In the most recent issue of the Astronomical Journal, Batygin and Brown present their research and demonstrate how Planet 9 explains a number of puzzling characteristics of the Kuiper Belt, an expanse of frozen objects and debris beyond Neptune. Although we were initially quite skeptical that this planet could exist, as we continue to investigate its orbit and what it would mean for the outer solar system, we become increasingly convinced that it is out there, says Batygin, an assistant professor of planetary science. For the first time in over 150 years, there is a solid evidence that the solar system's planetary census is incomplete. The theoretical discovery did not come about easily. In research released in 2014, Chad Trujillo, a former postdoc at Brown's lab, and his co-worker Scott Shepard noted that 13 of the Kuiper Belt's furthest objects share a mysterious orbital trait. They proposed the possibility of a small planet's existence to account for those similarities. Brown's interest was sparked despite his belief that the planet theory was unlikely. He took the problem down the hall to Batygin, and the two started what became a year-and-a-half-long collaboration to investigate the distant object. As an observer and a theorist, respectively, the researchers approached the work from a very different perspectives. Brown as someone who looks at the sky and tries to anchor everything in the context of what can be seen, and Batygin as someone who puts himself within the context of dynamics, considering how things might work from a physics standpoint. Those differences allowed the researchers to challenge each other's ideas and to consider new possibilities. I would bring in some of these observational aspects. He would come back with arguments from theory, and we would push each other. I don't think the discovery would have happened without that back and forth, says Brown. It was perhaps the most fun year of working on a problem in the solar system that I've ever had. Batygin and Brown rapidly noticed that the 6 most distant objects from the original collection of Trujillo and Shepard all follow elliptical orbits that point in the same physical direction. This is especially striking considering how differently their orbit's outermost points move around the solar system. It's almost like having 6 hands on a clock, all moving at different rates, and when you happen to look up, they are all in exactly the same place, says Brown. The odds of having that happen are something like 1 in 100, he says. But on top of that, the orbits of the 6 objects are also all tilted in the same way, pointing about 30 degrees downward and in the same direction relative to the plane of the 8 known planets. The probability of that happening is about 0.007%. Basically, it shouldn't happen randomly, Brown says, so we thought something else must be shaping these orbits. The first possibility they investigated was that perhaps there are enough distant Kuiper Belt objects, some of which have not yet been discovered, to exert the gravity needed to keep that subpopulation cluster together. The researchers quickly ruled this out when it turned out that such a scenario would require the Kuiper Belt to have about 100 times the mass it has today. They were then left with the notion of a planet. Their initial thought was to conduct simulations with a planet in a far-off orbit revolving around the orbits of the 6 Kuiper Belt objects, acting as a big lasso to pull them into alignment. Batygin claims that although it almost works, it does not precisely describe the observed aberrations. He says close but no cigar. Then, almost by accident, Batygin and Brown discovered that the distant Kuiper Belt objects in their simulations assumed the alignment that is actually observed if they were run with a massive planet in an anti-aligned orbit. An orbit in which the planet's closest approach to the Sun, or perihelion, is 180 degrees across from the perihelion of all the other objects and known planets.